Hello, this is another tutorial for IGCSE chemistry, and today we'll be looking into energetics, which is part of the physical chemistry unit, which is unit number 3, I believe. And this video is just a quick introduction into what energetics means, what it is, and the basics, basically, that you need to know coming into this topic. So a very essential part of this unit are endothermic and exothermic reactions. Now you may have heard these words being thrown around in your lab at some point in time, or this may be the first time you hear them. But the first thing you realize when you look at these words is that they're pretty similar. Actually, half of them is the same. This part, the thermic. And if you reflect on this for a bit, you will realize that maybe this is linked to thermal energy, which is of course heat, as you probably know from your physics class or some previous chemistry units. But the other half, the endo and exo, is not the same, and in fact these are opposites of each other. Endo in Greek, which is the origin of these two words, means in, and exo means out. So if we put those together, we realize that in the case for endothermic reactions, energy is going into something, and for exothermic reactions, energy is going out of something. Moving on from that, it is a very vital principle in this topic is that we're always referring to energy changes and energy transfers from the perspective of the system, of the reaction that's taking place, rather than from the surroundings. So let's say the system is isolated over here, and the surroundings, well, is everything else. If we have an exothermic reaction going on, exo means out, so energy will be going out of the system, thermal energy, out of the system to the surroundings. For endothermic reactions, we said endo means in, so the system accepts energy from the surroundings. Energy is going into the system from the surroundings. Okay? Now let's visualize this a bit more. Okay? Let's say one day you go into the lab and your chemistry teacher has set up this experiment for you. Okay? And you have test tubes number 1 and number 2, and he tells you, okay, I want you to identify which one is represents an endothermic reaction, which one is an exothermic reaction. But you don't know what's in the test tubes. You don't know what the reactants are, what the products are. All you can use is perhaps a thermometer, but not even that. Actually, all you can do is feel the test tubes. Okay, so you go ahead and put your fingers on test tube number 1, and you realize it's very hot. It's getting warmer and warmer over time. You do the same for test tube number 2, but this one is very cold. Let's analyze this. This seems pretty simple, but actually it tells us a lot about the nature of these two reactions. Okay. Now, why do you feel warm when you touch test tube number 1? Well, because energy is leaving the test tube and entering. Well, not entering, it's being received by your skin. So molecules and proteins or whatever in your skin vibrate more, and these cause receptors to go to send nerve impulses to your brain, which then say, oh, something's going on over here. This is warm. Okay, but the main thing you need to realize is that energy is going out of the system. So we can comfortably say that this is an exothermic reaction because energy is going out. In the case for test tube number 2, however, you feel cold. And why do you feel cold? Well, because you put your fingers are at, let's say, a temperature of 37 degrees Celsius, which is the average body temperature, okay? And energy is being drained from your skin to enter the test tube. So energy is in fact going into the test tube, into more appropriately the system. So we can comfortably say that this reaction is endothermic because energy is going into the system. This is a very important concept to realize, and actually many people get confused when they say, for example, the teacher tells them, okay, this is an exothermic reaction, but when I put the thermometer into the reaction mixture, is that I can see the temperature is rising. They may think, well, if the temperature is rising, surely the reaction system is absorbing more energy in. At the beginning, when I started the experiment, the temperature was lower. If I put the thermometer into the test tube, now it's warmer, so surely it's absorbing energy. But that's not the case, because the thermometer is the surroundings. Nothing can be the system than the system. So by inserting the thermometer into the test tube, what you're doing is basically replacing your fingers by a machine that can measure the changes in temperature and consequently the changes in energy. So don't be confused with that. When something is warm, you feel it's warm because energy is leaving the system. When it's cold, energy is entering the system and energy is being drained from your body. This seems like a very simple concept, but actually you'll be shocked to find out that many people, in fact, even if you think you've got this sort of it's under control, you may be surprised to find yourself making mistakes that are sort of silly if you understand them in the exam. So take good care of this and learn this, and make sure you properly understand this, because it's an essential topic. And this is the end of this quick tutorial. Next time we'll be talking about enthalpy changes, so keep an eye for that. Thank you very much. Goodbye.